Hello, it's James from XRobots.co.uk. This is part 5 of my BB-8 version 3. On my left we've got BB-8 version 2, which is a 10-part series you can see on my channel, and now I'm hoping to improve on that mechanically and in terms of features with version 3, which I've built up quite a bit here, done quite a bit of work on. Today we're going to have a look at the head control arm and the head mounting, but let's have a look at what we've done so far. This is version 3, so I've got my 3D printed ball. Check out part 1 for me making that and sanding it all smooth. Inside we've got this kind of internal hub, which I've called the banana for obvious reasons. And that's got lots of little guide wheels all the way around, which are 3D printed with 3D printed Ninja Flex tyres on. And those are all mounted on bearings. They help the banana run round in the ball. So obviously there's a drive wheel down there, which is the red tyre, which has a motor, a windscreen wiper motor, and that drives along, and obviously as it does so the internal drives and this rolls along. Now for side-to-side stability, which is what was missing from version 2, I've got the trousers, because they're like a pair of trousers hanging on the washing line, and those suspend a large amount of mass in the form of this flywheel, which can spin round to make the droid turn on the spot. And that flywheel and all the mass also shifts. So that has got another motor which moves with the flywheel on a toothed track, and that makes the droid shift side to side for steering and stability. So let's have a quick look at that. So if I just connect that motor to a battery that I've got just here and run it, you can see it leans over. Obviously it's really wobbly at the moment, and eventually it's going to be gyro stabilised. So that will make it lean over to stabilise or steer one way, and also back the other way if I move some wires out from under it. So that gives me quite a good angle of steer there for going around corners. So dynamically moving the trousers side to side will help kill this sort of wobble that we get, and in version 2 that was quite a problem because it does that both when it's driving and when it's stationary. So obviously we'll move that mass really quickly to compensate. Today we're going to try and build the head control arm, which of course will move the head around independently from both the banana and the trousers. This isn't going to be the head dome, this is what I used last time. This is the other half of a globe, which happens to be 280mm in diameter, so it's just the right size. For this version I'm going to do something quite special, and it's going to be much lighter. But anyway, we'll use this to demonstrate where the head goes for this discussion. So my original plan was to mount the head control arm on the trousers, so that as the flywheel moves one way, the head always stays on top essentially, because it remains always opposite. So if I were to move the flywheel over, then the head would go this way. And so I've just moved the flywheel to one side and we'd end up with the head over this side. So my head would remain on the top, or thereabouts, or obviously directly opposite the flywheel, until we then move it independently to some degree. And that made quite a lot of sense to me, because that's exactly how it works front to back. Essentially what happens is the head is fixed to the banana, and as the internal hub drives backwards and forwards to compensate and kill wobble and drive smoothly, the head of course always stays opposite, and then it's then biased by its own mechanism to point forward when it's driving forward and move around or do whatever it wants to do. So I was going to use the same logic to decide where the head should be mechanically, and keep that directly opposite the main mass that keeps this thing weighted down. However, that's going to be a bit of an issue, I think, because the flywheel's going to have to move side to side. The trousers here are going to have to move side to side quite quickly to stabilise this. So to kill the short, sharp sort of spikes in the motion, it's going to act a bit like a reaction wheel where it moves quite quickly side to side. And that's of course going to have the effect of moving the head quite quickly the other way side to side, which I don't really like the idea of, because I think it will throw the head off the magnetic coupling. So having given it quite a lot of thought, I've decided in fact what I'm going to do is mount the head control arm on the banana, and that's where the inertial measurement unit is also going to be, and then I can do what I like with this trousers and flywheel assembly, shifting it side to stabilise as quickly as I like. This is going to make more sense once I come on to do the electronics, but for now I need to make a mounting assembly to get the head control arm mounted onto this banana, the black piece, at either end. In a similar fashion to version 2, my head control arm is of course going to have a magnetic coupling at the top which grips the head from the other side. I'm going to make the head control arm a lot lighter and a lot simpler for this. I had fairly large 3D printed gears, 2 servos, another motor with 3D printed gears and all sorts of things. This one is going to be a lot simpler, so all I'm going to do is build a gimbal around this middle, which is why I've left this piece completely blank, to make a stick that sticks up, and then I'm going to push it around. The stick is also going to have a servo in the bottom that makes it turn, but that doesn't have to turn too much force, because again I'm going to split my head base into 2. Have a look at about part 2 or 3 of the version 2 build. I actually have a separate magnetic assembly that rotates inside the ball casters or the caster wheels on the head, so that I can turn the dome without turning all the wheels round. So we have a servo that turns the arm and some servos that push it round. So the basic plan is to have some of these servos, which are fairly large. These are high-tech HS805 BB Plus servos, which are rather large servos that do about 20 kilograms of torque. And I'm going to mount one of those each side, so one will be here, one will be on the other side. And simply put, that's all it's going to be. So I'm going to have some rather larger horns on these that push this stick around, so when both servos push forward, the stick goes forward. When they both pull back, it pulls back. And when one pulls forward and one pulls back, it should shift it sideways. And I should be able to get quite a bit of travel there. Now, I mentioned I was going to mount these servos on the trousers, so I was just going to have little brackets that put them here. I want to be able to do that in the future if this plan doesn't work. So the plan is to still mount them about here, only I will have a bracket to hold them onto one end of the banana, and there's still a bit of axle there as well to mount it on. So they will sit about here, and if the plan of mounting them on the banana doesn't work, then all I need to do is make an alternative bracket to mount them on the trousers, and they should have exactly the same effect and the same placement, hopefully. So the first thing I need to do is try and fit these servos in here by working it out in CAD, and then we'll build the gimbal and the rotational stick with the magnetic coupling on top. Right, we're back to the CAD for the whole assembly that I've got here. I've changed the ball to a transparent material so I can see through it, but nonetheless we can hide that and have a look right inside. So obviously, if we get rid of these as well, the purple parts there are crude 3D diagrams I've drawn of the servos that I've just shown you there. They are much larger than a normal servo, so it's been quite a consideration to fit them in. And they fit sort of on this plate, and the plate is mounted both to the banana, which is sort of green here, those are the black edges we can see in real life, with a bracket, and it's also mounted in here to that spare bit of axle. And you'll notice what I've done for accessibility is made sure that I can screw it on from the sides with these blue plates rather than from the top or bottom, because it's going to be very hard to get my hand in there once this plate is in place. So that should work pretty well. I can actually test moving the trousers and the flywheel rounds. This is the new version of 123D design, which is free, and it now has a smart rotate feature where I can select a face, which will be the end of this axle. I can select a solid, and then if I can find it, I can tilt it sideways. So I think I've got about 20 degrees of motion there, so I can see that my trousers don't run into anything. And I can tilt that back the other way as well, and we can test that out and check that everything's good. So here's that assembly on its own. I've built the top plate there in 2 parts, so I can print them both flat on the bed. They're both 6mm thick, and then I can take out any warp by screwing those back to back. The other bits and pieces will screw on, and hopefully that should all fit in there fine. Right, here it is. So I've printed all the parts and assembled them. I've solvent welded the 2 layers back to back, so you can see the seam, but you can also see that it's dead flat. That's just screwed in there for now. I could solvent weld it. Similarly these are. So this piece goes the other side of the axle and will eventually screw on to grip it, and these screw onto the banana. So there it is fitted. It's all screwed in and screwed in there, and it seems to fit fine. So I can move the trousers because I've tested that, and they move freely and don't get caught on it. Obviously they're off to one side there, and these servos seem pretty strong, at least from that point of view. They're attached to the banana pretty well. So now I need to implement the stick and the gimbal in the middle here, which will actually hold the magnetic coupling at the top. So that looks roughly like this. We've got this red part at the bottom which goes around the main axle. If I just hide this, we can see that we've got some 4mm holes that go all the way through to connect the two halves together, and we've got space in each side for an 8mm inner diameter bearing. So that should be able to be tightened around that aluminium tube I've got to get the right tension so it can move sideways. Then of course the other piece will rotate the other way, so that's got bolt holes that go in the ends. The servo fits in the middle that turns the head, and again we've got bearings in the top and bottom of the top part. So then of course that can move in all directions, which gives me my 3-axis, and I've laid all the parts out you can see around here for printing. They're all printed in 2 halves, so they're flat on the bed, and I can stick them back to back to get rid of any warp. Here we are, so those are the 2 halves. They go around the main axle, and this piece then hinges that way. So I've got the bearings pushed in there already. I need to put some 8mm studding through here and put a nut on each side. And I've got my other bearing here and here. So we're going to use a servo in the middle. This is a fairly high torque servo, but it is only a 180, so the head will only turn 180 degrees. I could put a 360 in, but for now that will do. And I need to attach something to these screw holes to hold the servo tabs either side, and then a piece of 8mm studding will go in the top, and I need to make a coupling to attach that to the servo horn so it can rotate. So let's get those bits and pieces made, and then we should be able to fit that in. The last part will be attaching something to these screw holes, which are the 2 couplings the other 2 servos will push to push this all around. So here we go, I've got those extra bits printed. I've got this thing attached to the top of the servo, and that eventually will have 8mm studding fitted in. It's pretty tight, so I need to screw it in. Then I've got this nut and bolt that can tighten up to grip it, and that's how that's going to work. And of course that's attached to the servo, and the servo's got this little bracket so that it can be fitted in here, and another bracket the other side to hold it, and hopefully that hole aligns okay there. So what I need to do is stick this studding in and put a couple of washers on so that we've got a bit of a spacer between the bearing, so that big grey thing effectively doesn't get pushed against there. There's no gap, so that stops the magnets pulling against this motor, and we should be able to pop that in. There we go. So I can now screw the studding straight into that hole and pop a couple of screws in there and a couple of screws in there, and now this servo should turn the studding, and of course on the other end is where the magnetic head mount is located, and this goes right in the middle of the droid. Right, so this is together. I've put some bits of studding in here, and I've put a slot in the end so I can screw them in, and a nut and some washers on the inside to get the spacing right. So of course this now fits over here and gets screwed into those bearings, so it can turn that way and it can turn this way. Right, here it is installed, so obviously it can move backwards and forwards and pivot side to side, and it's got loads of motion. So this is forwards, back not quite as far because that block is in the way where the servo is. But that's more than enough motion really. The servos probably won't be able to push it to that extent, and obviously we've got some restriction on the top because of the magnetic coupling which will hit these sides at some point. But that should be more than enough with the ball in motion as well. Hopefully you can see I've just installed a servo horn on here. So they came with round ones which are made of nylon and they're really tough. What I've done is put this kind of cam shaped thing on. There's a hole in the end there, and this can rotate all the way around. So the aim is to move the head stick by altering sides of a triangle essentially. So these two servos will come out to the head stick, and if I can change the two sides of the triangle, then I can of course move it backwards and forwards. And if I make one side very short and the other one side very long, it should move this way, and if I do it the other way, it'll move that way. But I do need some sort of flexible coupling to attach this onto the head stick, because of course the shaft will have to move around as the head stick moves. So let's see what that looks like. I've printed a piece, and this is printed on the Lulzbot Mini Flex extruder, so it's made of Ninja Flex and I can bend it. So this is going to mount up on here, and I've got a little shim that I made out of rigid ABS which can screw on to hold it to the two screw holes. So that goes on there, and that of course is the two mounting points, so these can bend and they can twist as well a little bit, which makes a sort of all-in-one universal joint really. They're also quite rubbery to push, so there's going to be a bit of flex which will act a bit like a dampener if there's any short sharp shocks. So I need to get some sticks and couple those with another flexible thing at the servo end. Right, I've made the arms, and I've made them out of partly Ninja Flex and partly out of rigid ABS, and I've just screwed that together, and I've put these extra holes in so they can bend really easily in one place. If it's too bendy, there is Ninja Flex Semi-Flex, which isn't quite as bendy. This is about 90% solid, so it's pretty much solid Ninja Flex. Obviously this goes onto the Ninja Flex parts I printed before, and this goes onto the servo horn so it can bend like that. So hopefully this will be good enough to see if the angles are right and these lengths are right, but let's fit those and see how it looks. Hopefully you can just about see I fitted that linkages in there, and I've put them on from both sides, so they're pretty firm. As I say, I might upgrade them to semi-flex. They don't actually need to bend that much, but I've got quite a good range of motion, so if I pull both the servos back, then my head goes completely back. If I push them forwards, that's about the end, it goes all the way forwards, and obviously one forwards and one back will bring it over sideways, and the other way brings it over there. That will go even further, so now that's over that side, and if I do a combination of them I can, you know, bring the head around in all sorts of motion. So I'm pretty happy with that. The only slight challenge is when it's completely back, there is a bit of wobble in them because the leverage angle is really sharp. The only way to solve that would be to bring these longer and bring them to in front of this. But when I actually move these and move them both forwards, then it's pretty much, there's a little bit of play, but they're pretty much locked in a straight line, so that seems to work out pretty well. Side to side motion is not too bad with the magnetic head coupling on there. I think that's as far as it's going to go anyway. I think that's going to be fine, so pretty happy with that. We're not really going to know how it's actually going to work till it's in motion, but on the whole I'm pretty happy. The other thing I'd like to add is that the Droid is still quite heavy in the bottom, so if I tip this over, it's more than happy enough to bring itself upright again. The other one just tipped over by itself sometimes, so although it's really wobbly, as I said before, that will be gyro stabilised by moving the trousers and the flywheel sideways quickly and driving the motor back and forth. But there is actually enough mass in the bottom that will bring itself upright. Now I still have the magnetic head coupling and the head to build, which I'm going to be doing next time. That's all there is for this episode. Next time I'm going to be coming back to build that magnetic head coupling that goes on top of the head control arm we built this time, and also most of the head structure. And if you want a clue to how I'm going to make that really light, have a look at the Star Wars Episode 7 Visual Dictionary image of BB-8. You can find it if you Google hard enough. That should give you a fairly good indication of how I'm going to save weight on the head. Alright, so I have actually published the CAD for all of the parts up to this episode on GitHub. If you have a look at github.com/XRobots, you can see both versions, 2 and in fact all 3 versions of BB-8 and my R6 droid. I'd suggest not following too hot on my heels in printing the parts, because as I've said in this episode and the last one, I may come back to revisit some parts. So I don't want anyone to waste too much time before I've actually got the electronics working and we can see how this handles in real life. So that's all for now. Don't forget to subscribe for more updates on this project and other projects, and also check out the social media links in the description to this video.